Hey all, welcome back. Some of the questions we already discussed, right? So I think some 9 questions we have already discussed in the previous session, right? So up to these questions we have discussed. Now in this session we are going to discuss these all questions, right? Your second question and again this question. Okay, all questions are very easy and concept based and very useful for JEE Main KEAM entrance examination and also other entrance examination conducted by the states, right? Now we can start our discussion, right? So this is our first question, and all the previous questions we have already discussed. That is available in tutorial number 1. Okay. Now I'll read this question, right? What the author says in this question. We have function f of x, right? This is a continuous function on R. We know R is a set of real numbers. And f of 1 by 4n, that is given as sine of e raised to n multiplied by e raised to minus n square plus n square by n square plus 1, right? Then we want to evaluate the value of f of 0, right? So they are given the function is continuous on R. So what that implies, limit exists, right? So we have limit, the limiting value, right? That means limit x tends to 0. F of x is equal to the exact value of the function, f of 0, since this is a continuous function, right? Okay. Now, this is our function is not given in terms of x. Function is given in terms of f of 1 by 4n, right? So they are given f of 1 by 4n. That is given as sine of e raised to n multiplied by e raised to minus n square, right? Okay, e raised to minus n square plus n square divided by n square plus 1. Okay. Now we want to evaluate the value of f of 0, right? Okay. So what happens when limit n tends to infinity? What happens to this term 1 by 4n? We can directly substitute n is equal to infinity. So this is equal to 1 divided by 4 into infinity, right? That is equal to 1 by infinity is equal to 0. So we get the value of f of 0 by applying limit n tends to infinity, right? Okay. So this is a trick we are going to apply here. So we can apply limit on both sides. So here we can apply limit n tends to infinity. Similarly, we can apply the limit on RHS also. Right. If we did some operation on LHS, we have to do the same operation on RHS also. Right. So this term becomes f of 0. That is equal to limit n tends to infinity. Sine of e raised to n. Right. So what's the value of sine of e raised to n? Going to write sine of e raised to infinity. E raised to infinity is infinity, right? Into e raised to minus infinity square. Plus we can apply limit here. Limit n tends to infinity. This term n square divided by denominator. I am taking n square. So we can write this as n square multiplied by 1 plus 1 by n square, right? Okay. Now what is the value of this limit? So this term, right? Sine of e raised to infinity. Sine of e raised to infinity is the value of e is 2.70. That is greater than 1. So sine of e raised to infinity is equal to sine infinity. What's the value of sine infinity? Sine infinity means any value between minus 1 and 1. This is the value of sine infinity. Okay. This is the sine graph, right? Sine graph. This is going towards infinity. Similarly, when this is going towards minus infinity. So what is the value? Sine is a bounded function. The maximum value of sine is 1 and minimum value is minus 1. So value of the sine will lie in between minus 1 and 1, right? So we can write sine infinity. That is equal to any value in between minus 1 and 1. divided by e raised to infinity square, right? This is minus, this will goes to the denominator, right? So the value of e raised to infinity square is infinity. So this term becomes minus 1 to 1, any value in between minus 1 to 1 divided by infinity. So any real number when dividing by infinity, that will result in 0. So this becomes 0. This entire term vanishes, that becomes 0. Alright. Now what's the value of this limit? This n square in numerator and denominator will cancel. So this is become 1 divided by 1 plus 1 by infinity square, right? 1 by infinity square is 0. So this is equal to 1 divided by 1 plus 0. That is equal to 1. Right. So what is the answer? So option A is the correct answer. Right. I think the problem is clear. Right. So the value of sine infinity or cos infinity, these both are bounded functions. Its values lies between minus 1 and 1. Right. Okay. Now we can look at our second question, right? And this is also a very simple question. Okay, a simple question. Okay. We have a limit. Now we want to evaluate the value, limiting value when x tending towards 0, right? So I'm writing the function here. What is our function? F of x. That is given as x, right? X multiplied by e raised to greatest integer function of x plus mod x minus 2 all divided by greatest integer function of x plus mod x, right? This is our function. And we want to evaluate the limiting value, right? What's the limiting value? Limit x tending towards 0 f of x. This is a good question, right? And options are also given. So in any problem which consisting of or which involves greatest integer function or modulus function, we have to evaluate left hand limit and right hand limit separately. If this exists and are equal, then we can say limit is existing, right? So here, what is the value of greatest integer function? Suppose limit is tending towards x 0 minus, that is left hand limit. What is the value of greatest integer of x? The value of this function is minus 1, right? And for x is less than 0, we know the modulus function mod x, that is equal to minus x, right? And for x greater than 0, mod x, that is equal to x, right? So this is a condition on mod x for x less than 0 and x greater than 0. So we can write x less than or equal to 0, mod x equal to x, right? Then what will happen? Limit x tends to 0 plus greatest integer function of x. That is equal to 0, right? So we got all the preliminary prerequisites, right? Now we can directly evaluate left hand limit and right hand limit. Okay. So first I am evaluating left hand limit, right? That is f of 0 minus, that can be written as limit x tends to 0 minus x, right? Inside this bracket, e raised to greatest integer function. The value of greatest integer function is minus x and mod x become minus x. Minus 2 divided by minus 1 minus x, right? Now we can directly apply limit. This becomes 0. X means 0 multiplied by e raised to minus 1 minus 0. Minus 2 divided by minus 1 minus 0. This is a real value, but this is multiplied by 0. So the value is 0. So left hand limit is 0. Now we can evaluate the right hand limit. Okay. RHL. Right? That is f of 0 plus. We can write this is equal to limit x tends to 0 plus x multiplied by e raised to latest integer function 0 plus x minus 2 divided by 0 plus x. Modulus of x is x, right? Okay. Now, what happens? The denominator becomes 0 plus x. What is 0 plus x? 0 plus x is simply x, right? This x in the numerator and denominator get cancelled. Now we can apply limit. E raised to 0 minus 2. That is equal to 1 minus 2 is equal to minus 1. So our right hand limit is obtained as minus 1 and left hand limit evaluated as 0. Both are not equal, right? Both are not equal. So what we have to say? We can say limit does not exist for this function. Limit does not exist. So D is the correct option. Okay. Now we can look at the next question, right? This is also a very simple question, right? This question can be done in different ways, right? Since if you are directly applying the limit, this tail become 0 by 0. Since sin pi by 2 is 1, right? So numerator become 1 minus 1 and cos pi by 2 we know 0. Denominator also become 0, right? And this also 0 by 0, right? And they are given the function is continuous at x is equal to pi by 2. We want to evaluate the value of b by a, right? Okay. So the same condition. This is a problem and limit, right? Limit is existing. So we can say the limiting value, limit extending towards pi by 2 f of x, that is equal to the value of the function f of pi by 2. Alright. Now this is 0 by 0. This, right hand limit is also 0 by 0. So we can apply L'Hospital's rules. But I am not going to apply L'Hospital's rules here. I am going to factorize the numerator, right? So you consider left hand limit, right? That is f of pi by 2 minus, right? That is equal to limit extending towards pi by 2 minus. The numerator is 1 minus sin cube x, right? 1 minus sin cube x. This is the form 1 cube minus sin cube x, right? That is a cube minus b cube 4. We know a cube minus b cube, that is equal to a minus b multiplied by a square plus ab plus b square. I am going to factorize the numerator, so we can write the numerator as 1 minus sin x multiplied by 1 plus sin square x plus sin x, right? Okay. So numerator is factorized. Denominator we have 1 cos square x, right? So 3 multiplied by 1 minus sin square x. Cos square x can be written as 1 minus sin square x. Now this is in the form a square minus b square, right? So we can write a minus b into a plus b form the denominator thing. So I am going to apply factorize the denominator also. So we can write the denominator as 1 minus sin x multiplied by 1 plus sin x, right? Now 1 minus sin x from numerator and denominator get cancelled. Now apply the limit 1 plus sin square pi by 2, that is 1 plus sin pi by 2, that is 1 divided by 3 multiplied by 1 plus 1, right? So this becomes 3 divided by 3. 3 from numerator and denominator get cancelled. So this is equal to 1 by 2, right? So the left hand limit is 1 by 2. 1 by 2. Okay. So we can say, so we got the value of a, right? The value of f of pi by 2. That is given as a. That is equal to left hand limit. That is equal to right hand limit, right? So left hand limit we already evaluated. So we can say a is equal to 1 by 2. So we got one value. Question is we want to evaluate the ratio b by a, right? Now we can go to our right hand, right? We can evaluate right hand limit. Okay, right hand limit. So we got the value of left hand limit as 1 by 2, right? And A is got as 1 by 2. Now right hand limit. Okay. So we want to find f of pi by 2 plus, right? So we can write limit x tends to pi by 2 plus b multiplied by 1 minus sin x divided by pi minus 2x whole square. You directly apply. The form is 0 by 0 4. So you can either apply L'Hospital rule or we can apply direct method, that substitution. We can put x is equal to pi by 2 plus h. So x tends to pi by 2 implies h tends to 0, right? So we can write this as limit h tends to 0 b multiplied by 1 minus sin of x is replacing by pi by 2 plus h, right? Divided by pi minus 2 into pi by 2 plus h, the whole square. Now we can cut and simplify, then we will get the answer. So this becomes limit h tends to 0 be multiplied by 1 minus sin pi by 2 minus h, that is cos h, right? Divide by denominator become pi minus 2 into pi by 2, that is pi minus 2h, the whole square. This pi and minus pi by cancel, the minus 2h square become 4h square. So we can write the denominator as 4h square, right? So this is a standard limit. This is a standard limit. This limit is a standard limit. 1 minus cos h by h square, right? We know limit h tends to 0, 1 minus cos h by h square. The value of this limit is 1 by 2, right? So we can write this as what is our right hand limit? B divided by 4 into 2. That is b by 8. That is again equal to but left hand limit or the value of f of 5 by 2, right? So this is equal to a, right? So what is b by a? B by a is given as 8. This ratio is a, right? So what is the option? So the option D, right? Option D is given as 8. Okay. Now we can move to next question. All right. Okay. It's a very easy question, right? So this is a left hand limit. Is given as mod x. When x less than or equal to 0 and x greater than 0, the value of this function is greatest integer x, right? We want to evaluate. We want to check. So they are given, this is the value of left hand limit when x tending towards 4. It's the value of right hand limit when x tending towards 2 plus from right side. And they are given the value of right hand limit is equal to the value of function at x is equal to 2. And the option D is less not exist, right? Okay. So we can evaluate left hand limit and right hand limit separately, right? So we know that mod x is equal to x if x greater than or equal to 0, right? Okay. Now what is the value of limit x tends to 2 minus, right? Left hand limit. You want to evaluate or check the limit with respect to the point 2, right? F of x. F of x is mod x, right? And we know that mod this is equal to limit x tends to 2 minus. 2 minus means this is 2, right? So this is 2 plus and 2 minus. The value of the function is x, the x. So the value is 2, right? Now, what is the right hand limit? That is limit x tends to 2 plus box x, right? That is equal to 2. So our left hand limit is equal to right hand limit. Then what is the value of f of 2? F of 2 that is given as mod x, right? Mod 2 is equal So this implies left hand limit is equal to right hand limit. That is equal to f of 2. So limit is x. So this b is a wrong option. This is minus 2. This is wrong. So this is wrong. So limit x tends to 2 plus f of x is equal to f of 2. C is the correct option. Now we can look at this problem, right? The very easy problem. All problems are easy, right? Only require some basic functions, right? So this is our question. F of x is given as 2 raised to x minus 1 divided by square root of 1 plus ax minus 1. We want to evaluate the limit x, no, the limit x tends to 0 f of x is given as log 4 to the base a. You want to find log what is value of a, right? We want to find the value of a. Okay. Now we can evaluate the limit, right? So we can write limit x tends to 0 f of x. F of x is 2 raised to x minus 1 divided by square root of 1 plus ax minus 1. By direct substitution, what we have 2 raised to 0 minus 1 divided by root of 1 plus 0 minus 1. That is 1 minus 1 by 1 minus 1. That is 0 by 0 form, right? 0 by 0. So we can apply L'Hospital form, right? So I'm going to rationalize this, right? So we can write, I'm going to rationalize. So 2 raised to x minus 1 multiplied by square root of 1 plus x plus 1 divided by square root of 1 plus x minus 1 multiplied by square root of 1 plus x plus 1. Then only this becomes mathematically balanced. Here also we have to apply the limit also, right? Limit x tends to 0, right? Okay, so we can write this as limit x tends to 0, 2 raised to x minus 1 multiplied by square root of 1 plus ax plus 1. This is the form a plus b into a minus b, right? By factorization, this and multiply. By using the identity, we get 1 plus ax minus 1 square. This plus 1 and minus 1 get cancelled, right? So the remaining term becomes ax in the denominator. So we can write this as x into a, right? This is a standard limit. Standard limit. So value is ln2, right? Into we can write put a x is equal to 0. So root of 1 plus 0 plus 1 divided by a, right? So what is the value? Value of this become 2 times ln2 by a. This can be written as this 2 is going to the power ln4 by a, right? That is given as ln4, right? The value of this limit is given as ln4. So what's the value of a? A is equal to 1. So we evaluate the value of a. So which option? Option B, right, is the correct option. Now look at this problem. Okay. Okay. Look at this problem. Okay. This problem, there is a small correction. Here, this is x raised to n plus 1. X raised to n plus 1. Okay, x raised to n plus 1. Okay. We want to evaluate limit x tends to 0 minus greatest integer function of x plus greatest integer function of x square plus x cube. This goes on, last term becomes x raised to n plus 1 plus n plus 1, right? All divided by 1 plus greatest integer function of x plus 4 mod x plus 2x, right? Now limit x tends to 0 minus. What's the value of box x? This is equal to minus 1. And similarly, limit x tends to 0 minus box of x square. This is equal to minus 1. For x cube, if coming inside the greatest integer, that we also will, or we can say general limit x tends to 0 minus x raised to n, that is equal to minus 1, right? Since suppose the value of x is some very good minus 0.1, right? So x square is equal to what happens to x square? X square is equal to, we get x square is equal to 0, which becomes square, right? 0.1 square, that is 0.001. So that is equal to 0. So this is not, okay, so this is right, this is not n. This is n plus 1 itself, right? 2n plus 1. Okay. There's one problem, that this is not that problem. In this problem, this is right as 2 raised to n plus 1. Okay, 2 raised to n plus 1. Okay. So we can evaluate. Right. There's some says some there's another problem. For that problem, that is x raised to n plus 1. For this problem, this is 2 raised to n plus 1 itself. Okay. We can say so. We can say limit x tends to 0 minus box x. This is equal to limit x tends to 0 minus x cube odd power. And this become odd power, what is x cube? For example, x is equal to minus 0.1. So this cube. So that is again is equal to minus 0.000. So 1, right? Like this. So the value of this greatest integer function is minus 1. Then x square, x raised to 4, x raised to 6, etc. The value of box becomes 0, right? When n is odd, the value becomes minus. I think it is clear, right? So how many terms totally we have? 2n plus 1 terms, right? So n plus 1 odd terms. While applying the limit, we have minus 1 plus minus 1 up to minus 1. How many terms? This is n plus 1 odd terms and n even terms. The even value becomes 0, right? Plus this is n plus 1 terms, right? Total n plus 1 terms and plus n plus 1, right? And in the denominator, this is not divided by n plus 1. This is used only to represent the number of terms, right? This is only to represent n plus 1. And denominator becomes 1 and greatest integer function of x, that is minus 1. Mod x become minus x plus 2x, right? Now we can simplify this. So this is how many minus 1 we have? N plus 1 minus 1, right? So we can write the numerator as minus n minus 1, that is n plus 1 into minus 1, right? So that is minus n minus 1 plus n plus 1. That's already given in the question, right? Now this divided by, we are applying limit x tends to 0, right? This plus 1 and minus 1 get cancelled, and minus x and 2x, that become x, right? Okay, so minus n and then become 0. Minus 1 and plus 1 becomes 0. So limit x tends to 0 minus exact 0 in the numerator. Denominator is x, but x is, this is limiting value. Limiting value is some 0.00001 minus, right? So numerator is exact 0. Exact 0. So we have said exact 0 divided by limiting 0, right? So the value is 0, right? So exact 0, concept is exact 0 divided by limiting 0. Limit x tends to 0, x. Limiting value of 0. Limiting value of 0 is not 0, not exact 0. So if we are approaching from left hand limit, that is minus 0.00001, very close. We are applying right hand limit. I can write 0 plus 0.00001. But in numerator is exact 0. So this is not 0 by 0, right? Exact 0 divided by limiting value of 0. So answer is 0. So which is our correct option? Correct option is A. I think this is clear. Right. Now we can look another problem, right? What is this the problem? Problem is a very simple problem. Okay, we can add, right? We we want to find the value of limit x tends to infinity. Log of x plus 2, but base is 10, plus greatest integer function of x plus 2. Right. Okay. Now, before going to question, in denominator we have greatest integer function of x plus a summation. First, we can evaluate the value of summation. Value of summation is summation r varies from 0 to infinity 1 by 2 raised to r. So we can write that is 1 by 2 raised to 0 plus 1 by 2 raised to 1 plus 1 by 2 raised to 2 plus 1 by 2 raised to 3 goes on. That is equal to 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube. This is an infinite GP. So sum to infinite term is a by 1 minus r, right? Sum to f and infinite GP. So we can write 1 divided by 1 minus 1 by 2. The value is 2. Right? The value is 2. Okay. So we got the value of this summation. That is 2. Now we can evaluate the value of limit. Right? We can evaluate the value. And raise this. Right. Okay. Now we can apply the limit. Limit x tends to infinity. Log 10 into x plus 2 plus greatest integer function of x plus 2, right? And denominator become greatest integer function of x plus the value of summation is 2. Here also x plus 2, right? And here limit x tends to infinity, right? We can evaluate 1 by 2. This greatest integer function of x plus 2 from numerator and denominator cancel. So this becomes limit x tends to infinity 1. So the value is 1. Right? Now what is the value of this limit? This is limit tending towards infinity. Tending towards infinity, right? Log of x plus 2 to 10. Right? What's the value of the numerator when x tending towards infinity? For suppose x is equal to x plus 2 is equal to some 10 raised to 6, right? The large quantity. Then what is the value of log 10 to 10 raised to 6? That is equal to 6. So numerator when x is not infinity tending towards infinity, numerator become a real number, right? Numerator become a finite value. Finite value, right? Logarithm. Logarithm. Suppose this log 10 raised to some 20. 10 raised to 20 is large value. So this 20 will jump here. The value of this become 20. So numerator become finite value. Finite value. And what is the greatest integer function of infinity? That is an infinity, but an integer. Infinity, an integer. That is equal to infinity, right? So finite value by infinity. That is equal to 0. Right. So the value of this limit is 1. So B is the correct option. Right? B is the correct option. Okay. B. 1. Right. Now we can look at this problem. Right? Limit x tends to 0 cos of sin x minus sin x, right? Divided by s raised to. So we can use cos A minus cos B, right? That is equal to 2 sin A plus B by 2 into sin B minus, and again B minus A by 2, right? Or we have to write a minus here, right? If I am writing sin of A minus. So we can write this as limit x tends to 0, 2 times sine of angle is sin x plus x by 2 multiplied by sine of x minus sin x divided by 2 or divided by x raised to 4. Right. Now we can simplify this, right? What will be the value of this 2 sin x plus x by 2 raised to x? Again we have sin x minus, right? And we know that limit x tends to 0, sine of some function f of x divided by some function f of x, right? Limit x tends to 0, sine of some function f. Inside here, the angle is some function of x, right? This is equal to 1. What is the condition? Condition is limit x tends to 0, f of x should be 0. Right? If the value of limiting value of f of x is 0, then what happens to this? This is become 0 by 0 form. And same angle. F of x is the angle, right? F of x angle. Same angle, sine of same angle divided by same angle. The value of limit is 1. Right? We are going to apply this trick here, right? So as to evaluate. Since the angle is given in terms of the function, right? So we know that when limit x tends to 0, what is the angle? Sine x, sine 0 plus x 0 by 2. That equal to 0. Again, sine x 0 minus sine 0, this angle, right? This function also tending towards 0, right? That's the value. So we can apply that trick here. Now I am going to write limit x tends to 0. This 2 into sine of sine x plus x by 2 divided by sine x plus x by 2. So as to convert into standard form, we wrote all these things, right? Now this term can write as sine of x minus sine x by 2 divided by the angle, that is x minus sine x by 2. So as to mathematically balance, we have to write these two terms in the numerator. So the numerator becomes, we can write numerator as x square minus sine square x, right? By 4 into an x raised to 4 is existing here, right? X raised to 4, right? Okay. Now what happens? The value of this limit is 1. The value of this limit also is equal to 1, right? Now the limit is reduced to limit x tends to 0. Here there is a 2, right? A 2 is here, right? So that 2 we are writing here. 2 into x square minus sine square x divided by 4x raised to 4. 4 I am writing here, divided by x raised to 4. Right. Now, what's the value of this limit that we have to evaluate, right? And we have to evaluate. Okay. Or we can write this as limit x tends to 0. 2 by 4 is 1 by 2. That can be taken outside. X minus sine x divided by x raised to 4, right? Into x plus sine x, right? Now this x raised to 4 can be split into 2. We can write this as x square, right? This can be write as, no, this is x. This term is x. So this term can be write as x cube, right? X cube. Okay, x cube and x. Okay, only some small mathematical manipulation. So x raised to 4, I split into 2 terms. That is x cube into x, right? We can write this in this form, right? That is mathematically right. Okay. So this becomes 1 by 2. That is limit x tends to 0. X. Now we can use the expansion of sign. That is x minus x cube by 3 factorial. That is 6. Plus x raised to 5 by 5 factorial. And higher order terms, right? All divided by x cube. This into, this becomes x by x. That's 1 plus sin x by x. Right? Now what is the value of this? This x and minus x will cancel, right? Now this minus of minus becomes plus. So plus x cube by 6, denominator x cube, and all higher terms of x. So this all becomes 0 when we are applying the limit, right? So x will come, higher terms of x will come in the numerator. So this x cube and x will cancel. There is a 1 by 2 is common here. Again, limit x tends to 0. Plus the value of this limit is 1 plus limit sin x by x. That is 1. Right. Now the problem is solved. So we can write this as 1 by 2 into 1 by 6 plus 2. Right? What's the value of this? Now we can simplify this. Simplify this and we will get the value of it. So that is equal to 1 by 2 plus 1 by 6, right? 1 plus 12 into 6, 12. 12 divided by 6, right? That is equal to 18 divided by 12. This option is available. So there is some mistake which happens. We can check, right? What is the mistake happens? It's 1 by 6. Yeah. What happens? This is not subtract, right? It's a product. Here it is product, right? Some calculation is this is a product, right? So 1 by 6 into 2. This is correct, right? That is not sum. I simply by error taken as sum. That is a product, right? So we can write this as this 2 and 2 get cancelled. So this is 1 by 6. So answer is 1 by 6. This is the correct option. The correct option is C, right? C is the correct option. Right. Instead of multiply, I just added. Right. Okay. Now this is a problem. This is also a very simple problem. We want to evaluate the value of limit x tends to 0, x tan 2x minus 2x tan x, right? So we can write tan 2x. What is the formula for tan 2x? Tan 2x is 1 minus tan square x divided by 1 plus tan square x, right? Now we can apply the limit. So limit x tends to 0, x into 1 minus tan square x divided by 1 plus tan square x, right? Then 1 plus tan square x minus 2 tan x divided by 1 minus cos 2x. We can write 1 minus cos 2x is 2 sin square x. So by squaring this becomes 4 sin raised to 4x, right? Now take the LCM, the numerator, and simplify. So we can write limit x tends to 0, x into 1 minus tan square x, right? No. Again, I did a mistake. First tan 2x, this is for cos 2x, right? Tan 2x is 2 tan x. 2 tan x divided by 1 minus tan square x, right? Actually, I am doing it a little faster. Let's make it simple. Limit x tends to 0, we can write x into 2 tan x divided by 1 minus tan square x minus 2x tan x, all divided by 4, 2 square means 4 sin raised to 4. From the numerator, we can take 2x tan x outside, right? So this becomes 1 minus tan square x, right? All divided by 1 minus tan square x into 4 sin raised to 4x. Now we can simplify and we get the answer. So this 1 and minus 1 will cancel. So the numerator becomes plus tan square x. So we can write this 2x into this tan x into tan square x. That becomes tan cube x, right? Divide by 1 minus tan square x, right? 1 minus tan square x. Multiplied by 1 by 4 sine raised to 4x. Okay. Now, what is the value of this limit? When limit is x tending towards 0, right? Okay. What will be the value? We can directly apply the limit. Here, before applying the limit, I am taking this 2 and 4 outside. So that can be written as 1 by 2, right? Taken outside of the limit. Then limit x tends to 0. Tan cube x, right? Tan cube x. So we can write simply an x cube. So as to convert it into standard form. Standard, we know limit x tends to 0. Tan x by x equals 0. So I have an x cube here. So here sine raised to 4x here. So as to convert it to 4 standard form, I wrote a 4 x raised to 4 here. So as to balance x raised to 4 here, right? And we have 1 minus tan square x. Tan 0 is 0. So 1 minus 0, right? Okay. Then x is here. Where is x is here? Okay. 1 x is here, right? So as to balance this x cube, we have to write x cube, right? Okay. So this x cube and this will get cancel. This x raised to 4 and this x raised to 4 will cancel. There is one x is already here. That x is wrong. So value of this limit is 1. Value of this limit also is equal, right? Now numerator x raised to 4, here also x raised to 4. So the answer is 1 by 2 into 1 into 1. That is equal to 1 by 2. So 1 by 2 is the correct. This option is available. Yes, the option is available. C. That's a very, very simple question, right? Now, look at the question. We want to evaluate the value of A, B, and C, right? A, B, and C, right? Since they are given, the value of the limit is given as minus 1 by 2. Okay. This also we can write sin A minus sin B, right? So we can write limit x tends to 0. Sin x, sin of sin x minus sin x, that is 2 cos sin x plus x by 2 into sin of sin x minus x by 2, right? Sin A minus sin, that is sin 2 cos A plus B by 2 into sin A minus B by 2, right? So we can write this. Now, what's the denominator? Denominator becomes a x cube plus bx raised to 5 plus c. Right? Now, what is the value of this cosine? When sin will be the limit, sin 0 is 0, x is 0. So this becomes cos 0, right? Cos 0. And the value of this becomes 1. Cos 0 is 1. So you can write this limit as 2 into, I'm writing the limit also here, that's considered for 2 into sin of sin, that can be converted into standard, right? Sin of sin x minus x divided by 2. So I'm writing the angle here, that is sin x minus x by 2. So as to mathematically balance, we have to write that in the numerator also, that is sin x minus x by 2 is not in the numerator. Divided by the polynomial, that is ax plus bx raised to 5 plus c, right? Now we can look the value of this limit, right? We can simplify this. The value of this limit, that is 1. So we can write this as 2 into. Now I'm going to expand this side. The function of x minus x cube by 3 factorial, that's 6, plus x raised to 5 divided by 5 factorial minus higher order terms. No need to write the higher order terms. Since limit x tends to 0, all the higher order terms into a. Here there is a minus x, right? This x is also minus, right? This is the expansion of sin x. Then a. This is where here is a 1, 2 is here, right? So this 2 and 2 get cancelled. So no need to write this 2, right? Okay. Now a into x raised to 3 plus b x raised to 5 plus c, right? From here we can evaluate the value, right? This value of this limit is given as minus 1 by 12. Okay, so this x and minus x will cancel, right? And here we can, so what's the remaining terms limit? X tends to 0 minus x cube by 6 plus x raised to 5 by 5 factorial minus higher order terms, all divided by a x cube plus b x raised to 5 plus c. Okay. Okay. Now, what is the value of this? This is given as minus 1 by 2, right? Now we can take x cube common, right? X cube common. So this term become dividing numerator and denominator by x cube. So this become minus 1 by 6 plus x square by 5. Okay. This term become bx square plus this term become c by x cube. Okay, c by x cube. That is equal to minus 1 by 12. Again, limit x tends to 0. The limit x tends to 0, whatever this term, this is equal to 0, right? Okay. And here, what happens? This becomes 0 is coming in the denominator, right? And what happens to this term? This 0, when 0 is coming to the denominator, that becomes infinity, right? So this b should be 0, right? No, b is 0, b into 0, right? b into 0, that equal to 0, right? So b is any real number. b is any real number. But what about this term? This term is c by 0. c by 0 means that becomes infinity, right? Infinity. c by 0 becomes infinity. But when infinity comes in the denominator, the entire term becomes 0. So that is not possible. So what's the value of c? This term should be 0. That happens when c is equal to 0. So c equal to 0 and b equal to any real number. b is equal to any real number. Then what is the value of the limit? Value of the limit is minus 1 by 6a. That is equal to minus 1 by 12. That implies a is equal to 2. So these are the values. So a equal to 2, b is equal to any real number, and c is equal to 4. A equal to 2, b is equal to any real number, and c is equal to 4. So a is the correct option. Okay. Now the limit is given. What's the value of limit? Limit is given as limit n tending towards infinity. Log 2 plus x minus x raised to 2a sin x divided by 1 plus x raised to 2. Okay. Now here option is f of is continuous at x is equal to 1. This is limit x tends to 1 plus f of x is ln 3. Limit x tends to 1 plus. So we need to evaluate limit with respect to the point x tending towards 1, right? Limit x tending towards 1. Okay. So limit x tending towards 1 minus, that is left hand side, for example 0.9999, this raised to infinity is equal to 0, and we know 1.00001, this is 1 plus, that is 1 plus raised to infinity, that is infinity. We are going to use this concept, right? So we can write limit x tends to 1 minus x raised to 2n, that is equal to 0. Similarly, we can write limit x tends to 1 plus x raised to 2n, that is equal to, why I wrote this limit? Because n x raised to 2n is coming in the function, so that's why I already evaluate this, right? Okay, so this concept we are going to apply here. Now we can evaluate left hand limit and right hand limit. Before that, we can obtain the function. What is the value of function f of x for x less than 1 and also for x greater than 1, right? First we have defined f of x, the built-in limit f of x, right? So for x less than 0, we can write this is equal to, for x less than 0, we can write f of x, that is limit n tends to infinity. First case is x less than 0, right? Log 2 plus x minus, this term become x raised to 2n. That's less than 1, not 0, x less than 1, right? Because we are evaluating the limit with respect to the point x into sin x divided by 1 plus x raised to 2n. So when x is less than 1, or limit x tends to 1 minus, right? This is 0. This is 0. So this term gets 0. This also equals 0. So our f of x is equal to ln 2 plus x, right? This term is free from n, so we can avoid the limit, right? Now what happens for x greater than 1? This is for x less than. Now we want to evaluate for x function for x greater than 1. So we can write our function as limit n tends to infinity. I'm taking x raised to 2n outside, right? Into ln 2 plus x divided by x raised to n, right? X raised to n minus sin x, since x raised to 2n is taken outside. And from the denominator also, I am taking x raised to 2n outside. 1 plus or 1 by x raised to 2n plus what is 1, right? So we can write this plus 1, right? Since when x tends to 1 plus, that is greater than 1, this becomes infinite. So this and this will cancel, right? So what is the value of this limit? The value of this limit is ln 2 plus x divided by infinity minus sin x divided by, this becomes 1 by infinity plus 1. So this is 0, right? This is also 0. So this becomes minus sin x, right? So our function is minus sin x if x is greater than 1 and ln 2 plus x if x is less than 1. Now we can evaluate, right? What is our left hand limit? Our left hand limit is f of 1 minus, that is limit x tends to 1 minus. The function is this, right? ln 2 plus x, that is equal to ln 3, right? And f of 1 plus, that is equal to minus sin 1, right? So limit does not exist. Both the values are different. Both the values are different. So what is the correct option? So this is discontinuous, and the value of right hand limit, that is minus sin 1. This is 1, right? Sin 1. Limit x tends to 1 minus f of x does not exist. Limit x tends to 1 minus f of x exists. The value is ln. So correct option is C. Okay. Now we can look our this problem, right? What they say, limit e raised to 4 by pi. 4 by pi tan inverse x minus 1 by x square minus 1. Right? If you are directly applying the limit, what happens? If you are directly applying the limit, then we get e raised to pi by 4. Tan inverse 1 is pi by 4. So 4 pi by pi minus e raised to 0. Right? Into 1 by x square minus 1 by 0. Right? So e raised to 0 by 0. If you are directly applying. So this is an indeterminate form. Indeterminate. Right? So we can't apply directly. So we have to make some mathematical manipulations. So we can write this limit as e raised to, we can take the limit on the power of x square power of e, x tends to 1, right? Into, I am going to simplify this by taking LCM. Tan inverse x minus pi divided by pi, right? Into x square minus 1. We can write this function like this, right? So what happens to the limiting value becomes 4 tan inverse 1, that is 4 into pi by 4 minus pi divided by pi into 1 square minus 1, that is equal to 0 by 0, right? Now we can apply L hospital source, LH. So what is the value? This is equal to e raised to the power is, we are applying x tends to 1, right? The derivative of tan inverse, that is 4 divided by 1 plus x square minus 0 divided by pi into 2x minus, right? Now you can apply the limit. E raised to 4 by 1 plus 1 square, that is 2, into pi into 2 into 1, that's it, right? So that is equal to e raised to 1 by pi. This is the answer. This is the correct option. Now look at this problem. Limit x tends to infinity, right? Here, this is a polynomial, square root. Inside the square root, a polynomial. Here also a square. So this is a form infinity minus infinity. This is an indeterminate form. So first we have to factorize this. Not factorize, we have to rationalize this. Rationalize, right? So rationalizing this limit x tends to infinity. Rationalization this becomes x raised to 6 plus ax raised to 5 plus bx plus cx plus d minus x raised to 6 minus 2x raised to 5 plus x cubed minus x plus 1, right? So as to make the equation balance, right? What do you have to do? We have to write the conjugate of numerator in the denominator, that is x raised to 6 plus ax raised to 5 plus bx plus cx plus d plus square root of x raised to 6 minus 2x raised to 4 plus x cubed minus x plus 1, right? Now we can simplify it. X raised to 6 and 6 cancel, right? And the numerator become a, we can collect the x raised coefficient of x raised to 5, right? A plus 2 into x raised to 5 plus b minus 1 into x plus c plus 1 into x plus d minus 1. I think that this is correct, right? Calculation is correct. Okay. So this is the numerator, right? Numerator, we wrote numerator like this, right? Now, applying limit x tends to infinity, right? Now divided by, we can take x cube common, x raised to 6 can be taken outside of. So when it is coming outside, this becomes x cube, right? X cube into square root of this we can write as 1 plus, here this is a by x, right? Plus b by x cube plus c by x raised to 5 plus d by x raised to 6, right? Plus inside this square root we can write 1 minus 2 by x plus 1 by x cube minus 1 by x raised to 6. X raised to 5, right? Plus 1 divided by x raised to 6, right? When limit x tends to infinity, what happens? What happens? This all terms become 0, and this all terms become 0. Here 1 inside the square root of the denominator 1. Here it is 1. It remains, right? Now we can reduce this as limit x tends to infinity a plus 2 x raised to 5 plus b minus 1 x cube plus c plus 1 x plus d minus 1, right? All divided by this is 1 and 1. 1 plus 1 2, right? So 1 by 2 can be taken out. This 1 by 2 coming from this 1 and this 1, right? This divided by x cube, divided by x cube, divided by x cube, divided by x, right? What is the question is given? The value of the limit is given as 2, right? The value of this limit is given as 2, right? That's a finite value. Okay. So we can write this as, that can be written as limit x tends to infinity. Here is from a plus 2, right? Plus b minus 1. This is x cube and x cube cancel. Plus c plus 1 by x square. Plus b minus 1 by x. That is equal to 2. This 2 can be taken to the RHS. So that becomes multiply LHS and RHS by 2. So this becomes 4. Right? Now, this is a finite, 4 is a finite value. So this should be 0, right? So, no, this is here, this is multiplied by x square, x square. So, and apply the limit and infinity will come here. That is not possible. So, a plus b should be 0, right? And the value of the limit is b minus 4. B minus 1. B minus 1 is equal to 4. And this term becomes 0, right? And limit and infinity, this becomes 0. And this also becomes 0. So C plus 1 belongs to R. And D minus 1 belongs to R. Any real number. C plus 1. So we can say A is equal to minus 2. B is equal to 5. C belongs to R. D belongs to R. Right? So what are the options we want to find? Okay. So A is minus 2. That is the correct option, right? The correct option is A is minus 2, right? A is minus 2. B is 5, not minus 5. This one, this one, this one. So A is the correct option. I think it is clear. Now we have problem sin x, right? Sin x. So limit x tends to pi by 2 sin x. So sin pi by is 1 minus 1 raised to 1. That is 1. Divided by 1 minus 1 plus what is log sin pi by 2 log 1. Log 1 is 0. So that is again 0 by 0 4. 0 by 0 4. So we can use L'Hospital or some other method. Substitution. I am going to apply the substitution method here. I am going to write it sin x is equal to t. Sin x is equal to, right? So x tends to pi by 2. What is t tends to sin pi by 2? Sin pi by 2 is 1. So t tends to 1. Right. So we can apply this limit as limit t tends to 1. T minus t raised to divided by 1 minus t plus ln t. Alright. So again, this is 0 by 0. Now we can apply L'Hospital's rules. Right. L'Hospital rule. So we can write limit t tends to 1. What is the derivative of t? That is 1. Derivative of t raised to t. That is t raised to t into 1 plus ln t. Divided by 0 minus 1 plus 1 by t. Now we can apply the limit. This becomes 1 minus 1 raised to 1, that is 1, into 1 plus ln 1, right? Divide by minus 1 plus 1. Minus, this is minus 1. 1 plus t, that is 1, right? 1 plus t, that is 1. So what happens? Numerator becomes 1 minus 1 plus ln 0 is equal to 0. Again, minus 1 plus 1. So that is again becomes 0 by 0 form. Okay. Now we have to apply L'Hospital rules once more, right? Once more. Because this is again 0 by 0 form. So again apply that. So we can write limit t tends to 1. The derivative of 1 is 0. Now differentiate this by making use of chain rule. So minus t raised to t. This is kept constant. So 1 derivative 1 is 0 plus 1, right? Then minus 1 plus ln t is kept constant. The derivative of t raised to t. What is the derivative of t raised to t? That we can write as t raised to t into 1 plus ln t, right? So this ln 1 plus ln t comes to that becomes square, right? So we can write that is a square. All divided by derivative of minus 1 is 0. Oh, derivative of 1 by t is minus 1 by t square. Now you can apply the limit. So while applying the limit, this becomes 1 raised to 1. That's minus 1 into 1 by 1, right? Minus ln t, ln 1 is 0. T raised to 1 is 0. So that is minus 1, minus 1. Divided by minus 1 by 1 square, right? So minus 2 divided by minus 1 that is equal to 2. So the answer is 2. This that is available in the option S. Option C. And we can do our last problem. Okay. Last problem. That's a very simple and some interesting, right? Limit x tends to infinity. R varies from 1 to 2016. R plus x all raised to 2016. Right? It's a previous year JEE. I think it is 2016 question. Right? We can write this. Okay. Now we can apply the limit. So this becomes when r equal to 1 plus x all raised to 2016 plus 2 plus x the whole raised to 2016. This goes on. Last time becomes R means 2016, right? 2016 plus x the whole raised to 2016, right? All raised to 2016. Now this divided by, we can take x raised to, actually this is infinity by infinity form, right? So we are right, that is indeterminate. I'm taking x raised to 2016 common from the denominator. So we can write this is 1 plus 2016 divided by x all raised to 2016. Okay. Now there is a small mathematical manipulation in numerator also. So you can write limit x tends to be. From this term, I am taking x raised to 2016 outside. So we can write this as 1 plus 1 by 2000, 1 by x raised to 2016. So 1 plus x by x all raised to 2016. Second term, we can similarly this term is taken outside. So we can write this as 1 plus 2 by x raised to 2016. And goes on. And last term, we can write as 1 plus 2016 by x. 2016 by x all raised to 2016. Denominator also we have x raised to 2016 multiplied by 1 plus 2016 by x. This raised to 2016. This gets cancelled, right? So here we have 1 by x, right? X is infinity. So 1 this term becomes 0. 2 by x this term becomes 0. This whole term becomes 0. So how many times? 2016 times. So the numerator we have 1. How many times? 2016 times. Divided by 1 plus this term becomes 0. Right? So answer is 2016. So option is available as option C, right? Okay. Now the next class we will discuss more problems on differentiation, method of differentiation and limit, right? Then we will discuss all the chapters or all the important concepts from all chapters that is useful for JEE Main aspects. Okay, thank you. Bye. We will see soon in the next